Hello and welcome to Indranath Roy's classes. In this video, I am going to explain you about two types of pointers. One is dangling pointer and memory leak problems. Basically, these are the problem caused when we play with pointers. So, without wasting time, let's begin. So, what is the dangling pointer? Dangling pointer I have written. It points to a memory location that already filled. Okay. When we have a memory location, especially in dynamic memory allocation, it happens. Don't worry, I will explain with example. Namaskar, I am Indranath Roy. In this video, I am going to explain you about two popular problems. This is dangling pointer and memory leak problem. These problems occurs when we play with pointers. When we handle memory with pointers, basically in dynamic memory allocation, it happens. So let's see it how the problem occurs and let's find the definition first. Please concentrate here. Dangling pointer. It points to a memory location that already freed. Okay, in dynamic memory allocation, we in the runtime we allocate some memory. Okay, that when we have the pointer, but the memory what which is it is pointing, it is already freed. Then we cannot use the memory. That is dangling pointer. As the storage is no longer available, told you na, the memory is freed. Trying to access it might cause segmentation fault. Segmentation fault is nothing but when we have refer some segment that is not there. So dangling pointer is a pointer that points to a memory location which memory location is not actually there. So with an example it will be more clear. So I am erasing it. Please note it down by pausing the video and please note it down. Yeah. First, uh, so here is a header file, hash include and all these things. Now header file and this is a function like void my func. Writings are little smaller, so void my fun. So here we allocate the memory like I am creating a character array char star c equals to malloc 16. What do we mean by that statement? Malloc is the function that is used for dynamic memory allocation. When we allocate memory dynamically, that is where then we use the malloc function. Okay, what it returns? It returns the base address of the memory. Suppose this memory is allocated 16 bytes. Okay, 16, 1, 2, 3, 4, 16 bytes is there. First location's address. Suppose it is 100. That will be returned to C. Okay, understood? So what is malloc? Malloc is this only. So first location. After that, what I am doing is free C. I am freeing the memory which is allocated by C. Okay, now when we do that, this like C of 1 equals to A. A. This will result a dangling pointer problem. This will result a dangling pointer problem because the memory, the 16 byte memory is already been freed. It is containing some garbage value or any other value. It depends on the machine to machine. But C1 equals to A, we cannot put any value to these locations. Why? Because the memory is no longer available. So this is the concept about dangling pointer problem. Now we will see about memory leak problem, how it is occurred and how to resolve it. Not okay. Now we will see about the memory leak problem. What is that problem? Actually, what happens is when we dynamically allocate a memory by malloc function or any other calloc function, then memory is allocated at the dynamically at runtime. But what happens is if we do not free the allocated memory, and we exit the program, what happens is the allocated memory remains the same. So we cannot access the memory again. The memory is leaked. Actually, some leakage will be there, and some memory will be not be freed. Right? Memory is important for running the program. So this kind of problem is called memory leak problem. So what is written here is the dynamically allocated memory which hasn't been freed. So which is not freed yet. So we are with an example it will be clear, more clear. So I am erasing it. Please take a note of it, and I am discussing an example. Suppose here is a header file. I function void my file. Yeah. Then after that same thing, I am creating a character array equals to malloc 16. So 16 byte will be dynamically allocated and the base address will be pointed by C. So after that, if we do not do anything and just leave it, what happens is the C will be gone. C will be gone, and as the program is over, the C will be gone, and but the memory allocated in the by the malloc function will be remaining. So we are having malloc function, but we are sorry, here in this function what happens is we are allocating memory by malloc function, and C will catching the base address at the program terminates. The here in this position C will be not be there. C will not be there. C is entirely vanished. So we cannot access this memory pointing by C. This memory is totally wasted. This is memory leak. We are having a leakage in memory. The memory is totally wasted. But in order to resolve it, we have to just use free function. Free C. If we do this free C, the memory will be free and there will be no longer any problem available. Okay. Thank you. Meet you in the next video.